Here I want to briefly discuss what aspects of chemical reactor design we should be taking into account when we choose the reactor temperature. The reactor temperature actually has a big influence in a number of aspects. And of course, there's not just one temperature. The temperature can change, for example, in a batch or a semi-batch reactor with time. And in a plug flow reactor, it can change with distance down the reactor. And for example, CSTRs in series, each one can be at a different temperature. So a number of things are affected by the temperature, and certainly one of the most critical ones is the reaction rate. For most reactions, the rate of formation, rate of reaction, is related to some rate constant, pre-exponential factor, and an exponential dependence on temperature. Now, certainly the concentration dependence could be more complicated and have other temperature dependence, but first approximation, this exponential dependence on temperature is quite important. Small temperature increases the rate a lot, which affects the reactor size, and so this certainly affects the reactor economics, and therefore reaction rate is one of the critical things that we need to take into account. Second one that's quite important is equilibrium limitations. If we were to look at equilibrium conversion versus temperature, as we raise the temperature for an exothermic reaction, the equilibrium conversion goes down. So this is exothermic, and of course most large-scale reactions are exothermic. So as we raise the temperature, equilibrium conversion goes down even though the rate goes up, so this is going to affect how we choose the temperature in the reactor. The third thing that is affected by temperature is the presence of side reactions. Most chemical reactions have multiple reactions taking place, and so selectivity is really critical. Sometimes it really governs the overall process. So I plotted log of rate versus inverse temperature. This exponential dependence, we expect straight lines. So if we have two reactions, and let's say reaction 1 is our desired reaction, this is desired, and at low temperature it's favored, at high temperature it's certainly not favored, and so selectivity changes dramatically with temperature. And selectivity matters because now much of our reactant could be going to a product that we don't want at the higher temperature, and also we could be creating a waste product that we actually have to spend money to get rid of. And so again, the economics get affected quite a bit by the side reactions and the selectivity. And fairly closely related to this, but not quite the same thing, is the product distribution. And what I mean by product distribution is, for example, in polymers, where we have a molecular weight distribution, the length of the change, the distribution of those lengths can be affected by the reactions. We're not, in this case, having selectivity to products that we don't want so much as changing the product and, again, changing the economics. So temperature is going to affect this because it affects the rate constants of the different reactions, say initiation and propagation and termination differently. So certainly something that's very important in thinking about the temperatures, what is our potential for thermal runaway? We have an exponential dependence on temperature, and so as the rate increases exponentially, this means the rate of heat generation increases exponentially. We certainly have major safety issues that we have to keep in mind, reactor stability issues, and temperature is pretty critical in these. The next thing on our list are the materials of the reactor. If you think about carrying out a chemical reaction, it could be at high temperature, we can be at high pressure, and we have reactive molecules, and therefore, what we make the reactor out of and how fast the reactor material could actually react, certainly a function of temperature, and this again very much affects economics. The next aspect is the physical properties of reactants and products, things like vapor pressure, boiling point. Does the liquid stay in the liquid phase at the temperature we pick for reaction? Solubility, when we look at gas liquid reactions, solubility is a function of temperature, and therefore that's going to affect the rate. Miscibility, other physical properties, viscosity, are going to change by temperature. And the last thing I'll add to the list here is the heat transfer area. So exothermic reaction means typically we have to remove heat. We have a jacket around the batch reactor. Do we have a sufficient heat transfer area? What's the maximum temperature we're going to get in the reactor? Can we control the temperature? Again, it relates to safety issues. Economics is paying for the heat transfer area, paying for the heat transfer system, and this is very much going to be affected by the rate of reaction, which is affected by the temperature.